Mr. Fox has 2 3/6 loaves of cornbread. Each loaf was cut into 1/6 size pieces. If he has 14 people over for dinner, is there enough bread for each person to have one piece? So first of all, we need to decide what is the size of one piece of bread relative to the whole. That means in relation to one whole loaf, what are the size of the pieces? Okay, those of you with your hands up, what size are the pieces?
1/6.
1/6 of a whole. Okay. How much bread does Mr. Fox need for 14 people? Now remember, we look back in our problem, how much bread is each person going to get? Class?
One piece.
So 1 piece. So if there's 14 people, how many pieces of bread do we need?
114. 114.
Okay, let me say it again. Each person needs, just think about reality. Each person needs 1 piece of bread. There's 14 people. How many pieces of bread do we need total?
14. 13.
Okay. This table and that table stand up. And Ethan and Jalen and Sean and Daniel, stand up. Okay, that's 14 people. If they each get 1 piece of bread, how many pieces of bread do we need? Raise your hand if you can tell me. If each one of those people gets 1 piece of bread, how many pieces of bread do I need to make sure I have in the class? How many?
14.
14. Not 1/14, not 1, but 14 pieces of bread. Okay, sit down. That wasn't, see, sometimes we're thinking too difficult. And I just want you to think about what makes sense. Okay, so the loaves are cut into into 1/6 of a whole loaf. We need 14 pieces of bread. We have a mixed number of how much bread there is. A mixed number is a number that represents some whole and some fraction. I want you to find the mixed number in this problem and circle it. Okay, what is the mixed number, class? 2 3/6 is how we say that. 2 3/6. Okay. So to find how many 1/6 size pieces are in 2 3/6, you can write 2 3/6 as a fraction. Right now it's not written as a fraction. Part of it's a fraction and part of it's a whole. So we need to write it as as a fraction. So here's one example. We have 1 whole here and 1 whole here. How many holes is that?
2.
2 holes. Okay? And then we've taken these holes and split it into 6, what would look like 6 like this. And we have 3 of those also here, because that's how much bread he has total. A hole, another hole, and then 3/6 of a loaf. Okay? So 2 3/6 is really just 1 hole plus 1 hole plus 3/6. Sorry. Just tell me I can't see it. So we have a hole, we have another hole, and we have 3/6, which looks like this. 1 hole plus 1 hole plus 3/6. Okay? Do we know how to change a whole number to a fraction that's easy to work with? Like if we were doing subtraction or addition and we were working with a whole, wouldn't you just change it to a fraction with the same denominator as the other part? What's our denominator here? 6. So I can change this whole into 6/6. See? They've divided it for you. 1, 2, 3, 4, 5, 6. Can I change this whole into 6/6 also? Yes, look. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then how many 6 do I have over here?
6.
1, 2, 3. We're just looking at the bottom. Okay, so I've changed this hole into 6, 6, this hole into 6, 6, and these 3, 6 are staying 3, 6. Here's a hole, and I have some 6. They're the same colors in the book. Look at how smart they are, right? Okay, looking up here, voices are off. Okay, I want you to go ahead and make your model on your desk like this. Okay, looking at the example here, we have one hole. Now look at your partners and think of your one hole with their one hole. Imagine, yours with mine. Imagine your one hole and their one hole, and imagine my 3, 6. So you have their one hole, your one hole, and my 3, 6. Would it look something like this?
Yeah. Yes.
Your one hole, their one hole, and my 3, 6 right here. Okay, let me go back up to my 3, 6. That would look like 2 holes and 3, 6. Right? Can I borrow your hole for a second, Shane? So it looks like this: 2 holes and 3, 6. Now, when you've separated them and separated those holes into 6, it now looks like how many 6? I want you to count your 6, your neighbor's 6, and my 6. And then raise your hand when you can tell me how many total 6 that is. Okay, now how many 6 do you have?
15.
15, 6. Now look back at the book here. And we took your 6th, your neighbor's 6th, and my 3, 6, and we ended up with 6 plus 6 plus 3, which is 15. 6. So here we did it with the model. Here we did it with the actual physical model. You're doing 5 thirds, you and your partner. Show what that looks like. All right, so Horace and I are going to show you. Yes, give me your hole. Okay. So here's 2 holes. Excuse me. Here's 1, 2, 3. These are thirds. These are third size pieces. 3, 4, 5. That is 5 third size pieces. 1, 2, 3, 4, 5. Okay. How many whole do I have there? How many whole pieces how many holes do I have? Class?
2.
No. Well, if I took these away, let's say I kept, there's 1 hole. Is this a hole?
Nope.
Is this 2 thirds here? Is that a hole, class?
No.
No. So how many holes do I really have?
1.
Just 1. And how many, what is my fraction of a hole here? Does this represent a hole?
No.
No, it represents what fraction, class?
2 thirds. 2 thirds.
2 thirds is right. Okay. I'm going to give you, now you kind of know what I'm looking for. It does not represent another hole because look at, here it is. Oops. Okay. Does it fill up the whole thing? No, there's a missing piece here. This is a missing 1 third right here. Okay, now you know what I'm looking for with your partner. I'm going to give you another one. Okay, do this one with your partner. How many holes do we have, class?
3.
Okay, let's start over. You have to only talk about one that is full. If the red bar is not full with the fraction that goes underneath it, it doesn't count as a whole. You can only count the whole if it is fully loaded with 8 size pieces. There needs to be 8 size pieces under it. Then you can count it as a whole. Are you listening? Thank you. So if it is a whole, if it is fully loaded with 8 size pieces, then it counts as a whole. If it is not fully loaded, it is not a whole. So how many wholes do you have represented, class? Show me with your finger. How many do we have, class?
1.
1 whole is represented. We have 1 whole. What is the fraction that's left over on the other side? Raise your hand if you can tell me. What is the fraction that is left over on the other side of your model? Nicholas? 4/8. Okay. All right, this time I want you to do, all right, how many fully loaded holes do you have? Remember, if it's not fully loaded all the way across, it doesn't count as a hole. How many fully loaded holes do you have? Raise your hand if you know. Okay, show me your fingers. How many? How many is that, class?
1.
And what fraction is left over? Ebony, what fraction is left over? 3 what? Three fourths. If I have 10/5, how many full holes do I have represented? Raise your hand when you know. How many full holes do I have represented? Okay, show me on your fingers. And how many is that? 2 holes. Do I have any fractions left over that are kind of just hanging there? No. So I have now turned this fraction into a whole number. It's not even a mixed number, is it? It's not even a mixed number. It's just a straight whole number, which is 2.